what living on each planet would be like. What if your grandchildren had eyes that could see in the dark, stood 8 feet tall, or breathed an atmosphere that would kill you instantly? As humans colonize the solar system, we won't just change our planets will change us. In 1,000 years, a human from Mercury might be as different from you as you are from a Neanderthal. From floating cities and acid clouds to mining diamonds from the sky, this is how we'll survive and evolve on each planet in our solar system. Mercury, the metal miners. Welcome to Mercury, where days reach 430 degrees Celsius and nights plummet to minus 180 degrees Celsius. A journey to Mercury would take about 3 to 4 months using a gravity assist trajectory past Venus. The first Mercury base would be established in the Terminator Zone, the boundary between day and night, where temperatures are manageable. Robots would land first to begin digging into the regolith. When humans arrive, they'd assemble prefabricated modules in these excavated areas, then cover them with several meters of regolith for radiation protection. These underground habitats would expand over time, with sealed environments and advanced air recycling systems essential for survival. To solve the water problem, special expeditions would travel to permanently shadowed craters at the poles where ice has been detected, using insulated vehicles during Mercury's long night cycle. For food, Mercury colonists would survive using underground hydroponic farms, lit by efficient LEDs, and lab-grown proteins for dietary variety. As the colony grows, Mercury's abundant metals would become its economic foundation. Robotic miners would extract iron and titanium during cooler periods, while humans direct operations from shielded habitats. Inside these protective enclaves, life would adapt to Mercury's unique condition, and so would the colonists themselves. After generations underground, Mercury humans would undergo fascinating changes. In the planet's 38% Earth gravity, they would grow taller and more slender, with less bone and muscle density. Their skin would become paler from limited sun exposure, while their eyes would develop better night vision for the dimly lit underground communities. These physical changes would be so profound that Mercury-born humans might never be able to visit Earth, as our homeworld's gravity could fracture their weaker bones. After 100 years, several underground cities would house thousands of people, connected by tunnels and powered by massive solar arrays that capture the intense sunlight despite needing advanced cooling systems. After 1,000 years, Mercury would be transformed into the solar system's mining hub. The entire population would live in sprawling underground complexes, with giant mass drivers launching resources to other planets using Mercury's abundant solar energy. A civilization literally forged in fire and darkness. Venus, the cloud dwellers. Ever dreamed of living among the clouds? On Venus, it's that or die. The surface melts lead, crushes submarines, and dissolves your lungs in seconds. But 50 kilometers up, paradise awaits. Venus is our closest planetary neighbor, with a journey taking only 3 to 5 months. Our first settlement wouldn't land but would float in Venus's upper atmosphere. Large structures filled with breathable air would naturally float in Venus's dense CO2 atmosphere, just like balloons on Earth. To stay in place, they'd use powerful propellers and strategically ride different wind currents at various altitudes, like a ship using both its engine and carefully positioned sails to maintain position. These cloud cities would be multiple-chambered structures designed so damage to one section wouldn't sink the entire habitat. Their exteriors would need acid-resistant coatings to withstand Venus's sulfuric acid clouds, while filtration systems would make the toxic atmosphere breathable. Venus cloud dwellers would pioneer floating aquaculture with tilapia and spirulina tanks, alongside compact aeroponic chambers for fast-growing vegetables, safely isolated from the toxic atmosphere. Water would be extracted from acid clouds through chemical processing, while generating power from advanced wind turbines using Venus's 700 kilometers per hour winds. As these floating communities grow, colonists would develop a lifestyle unlike anything on Earth. Transportation between cities would use specialized airships riding Venus's powerful wind currents that circle the planet every 4 Earth days. Essentially, a planet-wide wind-powered transit system. But while this may sound glamorous, life in these cloud cities would change human biology in ways you'd never expect. First, the constant motion would make their balance super sensitive, way beyond a sailor's sea legs, causing cloud-born children to walk with a weird sway that Earth people would find strange. Second, the filtered sunlight would turn their skin a yellowish gold color, while their eyes would grow larger and more sensitive to help them see in the dimmer light. After 100 years, dozens of floating cities would house millions of people, and after 1,000 years, Venus humans would be golden-skinned people with large eyes who move with dancer-like grace. That is, until they visit solid ground. Meanwhile, Venus would begin terraforming its surface, while the floating cities remain humanity's main home. Earth, the birth world. While humans explore new worlds, our home planet transforms too. With heavy industry moving to space, Earth would focus on healing itself. Massive reforestation and ocean cleanup projects would restore natural ecosystems. Cities would be rebuilt as efficient, sustainable urban communities, while former farmlands return to wilderness. Earth humans would change little physically compared to their spacefaring cousin. With cleaner environments and medical technologies developed for space, lifespans would increase. However, they'd remain adapted to full Earth gravity, eventually making them distinct from humans born elsewhere. After 1,000 years, Earth would become a carefully managed garden world, a living museum preserving the incredible biodiversity that exists nowhere else in the Mars, the Red Pioneers. Meet your future grandchildren, 8 feet tall, barrel-chested, and faster than Olympic sprinters. But too fragile for Earth. That might seem extreme, but with thousands of years of evolution on Mars, it might not be as far-fetched as you think. Mars is relatively accessible, with journey times of 7 to 9 months using conventional propulsion during optimal launch windows that occur every 26 months. The first Mars settlers would transform raw Martian terrain into a livable world, turning the planet's own dust into Marscrete, radiation-resistant bricks that would form underground habitats. Drilling teams would extract water from hidden ice deposits, while advanced processors would pull oxygen from the carbon dioxide atmosphere. In carefully designed greenhouses, the planet's abundant CO2 would become an unexpected ally, accelerating plant growth in sterile habitats that slowly bloom green against the red landscape. For food, Mars colonists would grow hardy crops in these greenhouses using Martian soil enriched with organic waste, while raising protein-rich insects requiring minimal resources. Energy would come from solar arrays and small nuclear reactors, providing consistent power during dust storms. Mars's low gravity would reshape human physiology from the ground up. Bones would grow longer and more slender, enabling heights up to 8 feet, while massive barrel-shaped chests would develop to extract oxygen from the thin atmosphere. These future Martians would become lightning-fast sprinters with lean, elastic muscles, fragile by Earth standards, but perfectly optimized for their harsh red world. After 100 years, several cities would emerge beneath massive dome structures, housing millions who move effortlessly in the low gravity. By 1,000 years, Martian humans would stand 8 feet tall, with targeted genetic modifications that allow cells to recover from radiation exposure 300% faster than unmodified human cells. Their bodies would be distinctly alien, pale, translucent skin stretched over 8-foot frames with enormous dark eyes and massive chest cavities, built for survival on Mars and nowhere else. Jupiter, the Sky Miners. Welcome to Jupiter, where clouds are your floor and a fall never ends. Reaching Jupiter takes 2 to 6 years, depending on the propulsion technology and trajectory. The enormous distance requires multiple gravity assists from inner planets to save fuel. With no surface to land on, our habitats would float in Jupiter's upper atmosphere. These stations would essentially be massive balloons containing lightweight gases inside rigid shells, similar to those that would be used on Venus. Powerful thrusters would maintain position against Jupiter's strong winds. Heavy shielding would protect against Jupiter's intense radiation, using physical barriers and electromagnetic field generators. These compact habitats would focus on resource harvesting. Jupiter's atmosphere contains abundant hydrogen and helium-3, perfect fuel for fusion reactors that could be used for power generation on Jupiter and throughout the solar system. Specialized drones would dive deeper into the atmosphere to collect these gases, built to withstand increasing pressure and temperatures. Food would come from hydroponic systems, using artificial light, as sunlight at Jupiter's distance is only 4% as strong as on Earth. Jupiter's floating habitats would focus on industrial operations rather than agriculture, with small hydroponic gardens for fresh greens and most food imported from its more habitable moons. Water would be extracted from Jupiter's atmosphere using condensation systems that cool the gas to liquid, with additional supplies shipped from its ice-rich moons. Jupiter humans would look distinctly different after generations in their floating habitats. Their skin would become noticeably paler, almost translucent due to Jupiter's dim sunlight. Their eyes would appear much larger with oversized pupils to capture more light, giving them an owlish appearance. The constant exposure to pressure changes would reshape their ear canals and give them slightly elongated earlobes. After 100 years, dozens of floating cities would hover in Jupiter's clouds, housing thousands of specialists. After 1,000 years, Jupiter humans would be immediately identifiable by their chalk-white skin, large dark eyes that can see in near darkness, and unique ear structures. At this point, Jupiter would also become the solar system's main fuel source, with its floating refineries producing enough helium-3 to power human civilization across all planets. Most humans in the Jupiter system would eventually live on its moons, especially Europa and Ganymede, while the floating cities would remain specialized industrial outposts, operated largely by these uniquely adapted humans. Saturn, the Ring Riders. Saturn's rings contain enough ice to fill Earth's oceans 30 times over, and we'd mine every drop. It lies about 1.2 billion kilometers from Earth, with journey times of 3 to 7 years, depending on the propulsion technology and planetary alignments. Like Jupiter, we'd establish floating habitats in Saturn's upper atmosphere using hydrogen-filled structures. These would need constant heating from nuclear reactors to combat Saturn's frigid temperatures of -178 degrees Celsius. The real advantage of Saturn is its magnificent rings and many moons. While some would live in floating habitats harvesting atmospheric fuel, most would settle on Saturn's moons, particularly Titan with its thick atmosphere that provides excellent radiation protection. Saturn's colonies would primarily grow food on its larger moons like Titan, using enclosed agricultural domes, while ring mining stations would rely on compact hydroponic systems for basic fresh produce. A unique Saturn industry would be ring mining, facilities positioned within the rings to harvest ice and minerals from the countless particles, collecting these materials as they naturally pass by. Saturn would create not one, but two human subspecies. Ring walkers, living in the rings, would develop pale skin with a silvery sheen from radiation exposure, with subtle geometric skin patterns that help reflect harmful radiation. Titan dwellers would evolve orange-tinted skin and reflective eyes to match their moon's dim orange atmosphere. After 100 years, Titan would host several domed cities housing millions, while ring stations would extract valuable water and minerals. After 1,000 years, Saturn's ring walkers and Titan dwellers would evolve into such different subspecies that they'd need special breathing equipment and gravity adjustments to visit each other's environments. Their distinct appearances, one pale with enhanced vision for ring navigation, the other orange-tinted with reflective eyes, would make them immediately recognizable throughout the solar system. Uranus, the tilted world. On Uranus, you'd experience 42 years of complete darkness, followed by 42 years of non-stop daylight. So how would humans survive? Uranus is about 2.6 billion kilometers from Earth, with journey times of 8 to 12 years using conventional propulsion. Unlike the gas giants closer to the Sun, Uranus colonies would focus primarily on moon bases rather than atmospheric operation. The extreme cold -200 degrees Celsius and distance from Earth would make establishing permanent bases on its 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, the priority. These moon bases would be built into the icy crusts to utilize geothermal energy where possible. Transparent domes would be strategically positioned to capture the faint sunlight during the long summer seasons, with massive energy storage systems to survive the equally long winter darkness. Uranus colonists would rely on controlled indoor agriculture, but would alternate crops based on the 42-year cycle, growing light-hungry fruits and vegetables during the long summer when natural sunlight could supplement artificial lighting, then switching to more efficient root vegetables and grains during the decades-long winter. For water, that would be extracted from ice mined on Uranus's moons. The main resource industry would focus on quantum materials, exotic crystalline structures that only form under the extreme cold and unique magnetic conditions of Uranus's moons. These materials would revolutionize computing and energy transmission throughout the solar system. Living in Uranus's conditions would change colonists physically. Their eyes would become extremely sensitive to catch the faint sunlight, appearing much larger with unusual purple-blue hues. The pupils would develop a distinctive oval shape to maximize light gathering, giving Uranus humans an otherworldly gaze. Since Uranus receives just 0.3% of Earth's sunlight, habitats would be kept dimly lit to conserve energy. Even with regular fuel shipments from Jupiter and Saturn's hydrogen harvesting operations, power would remain precious. The cooler habitat temperatures would cause humans to evolve thicker fat layers under their skin for warmth, giving them a rounder, softer appearance than humans from warmer worlds. After 100 years, Uranus would remain sparsely populated, with a few thousand specialists on the moons. After 1,000 years, Uranus humans would be immediately recognizable by their large oval-pupiled eyes and rounder bodies. Their constant exposure to the specialized quantum materials would also give their hair a subtle glow in darkness, a side effect that would become a prized physical trait. Neptune, the blue frontier. On Neptune, storms the size of Earth rage at 2,000 kilometers per hour, and it literally rains diamonds. But could humans harvest this treasure trove? Neptune lies about 4.3 billion kilometers from Earth, a journey taking 12 to 15 years with current technology. Our Neptune habitats would be tough, spherical structures built from carbon materials made from Neptune's own methane. Unlike stations on other gas giants, these spheres could dodge storms by changing altitude, sinking below dangerous weather when needed. Powerful thrusters and gyroscopes would keep the habitat stable even in 2,000 kilometers per hour winds. We'd also establish bases on Triton, Neptune's largest moon, which has nitrogen geysers and temperatures of -235 degrees Celsius. These moon bases would serve as the main population centers, safer than the floating habitats. Neptune outposts would rely on compact, highly controlled farming modules, growing calorie-dense crops and basic vegetables, while water would come from mining ice on Triton. Due to the extreme isolation, all food and water would be strictly rationed to avoid running out of provisions. Power would come entirely from nuclear fusion using fuel harvested from Neptune's atmosphere, but could also be imported from Jupiter. A unique Neptune industry would be diamond harvesting, collecting diamond particles formed in the atmosphere where extreme pressure transforms methane into carbon crystals. Neptune would create two distinct human groups, similarly to Saturn, habitat dwellers and moon colonists. In the floating spheres, constant vibration and motion would transform humans over generation. Their inner ear structures would adapt, giving them exceptional balance. Their bodies would naturally develop denser leg muscles to maintain stability, creating a distinctive stocky lower body appearance. Meanwhile, on Triton, the extremely low gravity, 8% of Earth's, combined with the cold, would create taller, thinner humans. Most striking would be their unique skin. A reaction to Triton's nitrogen-rich environment would cause their skin to develop a natural pattern of lightly frosted stripes that improved circulation in the extreme cold. After 100 years, these populations would remain connected but physically distinct. After 1,000 years, sphere folk, with their powerful balance and sturdy builds, would rarely intermarry with the tall, frost-striped Triton clan. Despite living in the same planetary system, these two groups would become the most different from each other of any human subspecies. Neptune would mark the edge of human civilization, our final outpost before the darkness of deep space. From this distant frontier, Earth would appear as just another star, once our only home, now just one of many worlds shaped by human ingenuity. The children of Earth would have become as diverse as the planets they inhabit, their bodies transformed by the worlds they conquered. So, which planet would you choose to live on? If you liked this video, subscribe for similar ones or leave a comment to suggest another.